Welcome, everybody. So first of all, I would like to say a little bit about the effectiveness, whether Agile is an answer, and what we can do about this. Considering where we are right now, Agile is a great vehicle, but this is something we can build upon. And actually, concept of technical debt, ability to deliver customer value over time, and being able to maintain that ability is very important. Technical debt is being experienced by us by the consequence of its presence. It actually slows down development time. It has some issues with, causes some issues with testing, stabilization of the product, and ultimately it may impact the developers' morale. But here I would like to show how we may bridge the gap between business and engineering to show that we can have the model for both to maintain the area of responsibility, but to cooperate fluently, and to show how this model may work through the example actually I made. Thinking about perceptions we may have, business in the eyes of engineering may be perceived that only this short-term perspective is valid, important, and that refactoring is actually something which does not bring any value. On the other hand, engineering, perceived by the business, may be seen as guys who has just tunnel vision, just craftsmanship over real value, and that they will neglect future direction and actually business focus and ability to earn money. So there is a tension. However, if short-term business perspective is not addressed, we may have no long-term perspective. If long-term engineering needs are neglected, development will stall and the morale will sink. So first of all, thinking and reasoning about technical debt, we should build a common ground, what it actually is, and how we may discuss about it. When we see the picture, then definitely this is the bed, right? However, is the bed comfortable? Is the bed good enough? So the bed is our software artifacts, the classes, the way we actually, the stuff we are developing. The question about being suitable, comfortable, good enough is the domain of technical debt. So thinking about this, we may see it's like areas of the product which may be compromised, or quality aspects like QAs here, which may be compromised for a given product. We simply know and reason about what is good enough, what is suitable for us, and where we are right now. So when we draw this chart showing the line of what is the desired state, and where we are right now, we have the gap, which is in green color, and this is showing the actual state of technical debt. Considering the definition, it refers to immature software development artifact. We want to get something faster sometimes, and this is important, but over time, it has delayed consequences. Technical debt as a whole embraces all software development artifacts, actually all of the states and differences, and the deviation from the desired optimal state. However, this is not only the actions of engineers which may cause technical debt to grow. This also be the change of surrounding solutions, evolving technologies, their adoption by the industry, or something we have experienced in our product, like mergers and acquisitions. When we acquire a new company, it's simply shown that we need to support more in a different way, and suddenly the solution which was good enough stopped becoming good enough. And the context is the key. What is considered technical debt in one system may not be considered in another. When we think about the product area with some challenges, which will be developed further, which will be the baseline for future features, and there is extensive amount of them, the amount of debt in such area will be high. But if something is in the area which is going to be retired, is good enough, doesn't bring us any problems, Actually, we should consider technical debt as zero value there. Then we need to also put in understanding what is actually the product. When we think from automotive example, we see the car which is approaching the crossroads, and there is a warning that red light violation was discovered from the cameras, from the system surrounding. So this is not just a car. This is the ability to get the information and actually to get safely to the destination. Considering video security, it's not just a camera. We may see like a person loitering or maybe doing some strange things being discovered by the camera, and ability to inform effectively the operator is something what is important. So we need to take the broadened product view, a service for a customer, not just a car or a camera. Also, during development, we need to think about all of the artifacts, software artifacts we are creating, not just the code of the application, but also our automating testing environment, simulators, other artifacts like DevOps stuff, which is required to deliver value effectively to customers. When I got a question that probably we may skip some stuff in simulators, or maybe they do not need version control and they are not treated the same way as the normal product, or actually the application code, I'm saying, okay, throw it away. Why you need it? But I needed to deliver faster, to test it, to prove. So this is your part. This is the part of your product. You need to take care about this in the same way as you are taking care about new functionality being developed, because this provides you, this gives you the ability to deliver value to customers. So the more product becomes a service, and this is the way how we should reason about it, the more such perspective is required. So this is the picture of Atlassian DevOps Marketplace and the stack. We may see a bunch of applications which are supporting the development. And actually, if we prepare some code to support the way we are delivering value to customers, this is part of our product. This is part of our solution. So to recap this part, first of all, before saying that we have huge technical debt, I'm trying to get my developers to discuss what is the desired state and why, and whether they agree on it. Sometimes they are not. Then just checking the current state, quantifying the difference, prioritizing, and finally reducing where it brings value. And how to find the value in technical debt, why it is important, how we can quantify it. So during the couple of years and experimentations, the CoDVA Continuous Debt Valuation Approach emerged. First of all, we need to think about how responsibilities are being split. Product manager is a role which is facing customer external business needs. Product owner is engineering facing. They have their own domains. They need to cooperate, but also they need to retain some authority over this domain. Then we need to have to take into account business perspective to see more than just one or two features ahead, but to see the funnel, where we find benefits, what is important for us. When we think about the value, even from business perspective, there is no universal formula. We may have products to support business evaluation like Product Board, Savio, or AHA. Each of these enables to create customized formula for value creation. It may take some strategic needs, some conformance requirements, of course, benefits in terms of money, but there are more and more aspects to be taken into account. However, engineering does not need specific information about money. They do need information, what is the priority order for these functionalities over time. When we took into account technical debt evaluation, there are many tools which may try to do so, but we try to think about something which is bigger than just adherence to code quality or some aspects like that. So enablers for simulator testing, refactoring of modules to provide ability to add new functionalities, enabling unified logging monitoring mechanism across the whole application, etc. These kinds of stuff were items which were important to prioritize. Those adherence to code standards may be seen as small tactical items, which may be taken into account as a part of definition of done. When we think about the dynamics, first of all, we do have the perspective of the business. Business is taking into account the opportunities in the field and doing the prioritization in the continuous manner. They should have this ability to create funnel, what is most important, where we can find biggest benefit for the company and return of investment in engineering work. They are creating prioritized product roadmap, and this is being created in, for example, AHA. Later on, or actually in the same time, engineering, knowing what they are maintaining and developing, they do create the log of technical debt from the perspective of ability to deliver new functionalities, what is needed, what is actually missing, and thinking about the challenges they are facing. Then, and here's the heart of the solution, comes the mapping. So I will spend a little bit more time here. We can take the example that engineering is identifying, like, for example, 4 technical debt items. Then they are costing them to make things easier. I just show this is like small, the t-shirt sizing. Then we have features on the roadmap and information how they are important for the business. This is feature priority. And as you see, this is from 0 to 1, so this is relative priority. We do not need to know exact money, but we just need to know what is important and how much. Then we also know what is the size of the feature. And RSS is the parameter we put into account to understand how big amount of changes we may expect. If the future roadmap is changing very frequently, it's more important to focus on the features which are closer to the date. If the roadmap is quite stable, we may see longer and longer in future. And we see also how these features are assigned to particular releases. But considering continuous delivery, we may put it like, for example, how they are assigned for quarters in the year. So we do have the mapping, and also very important is how much a particular technical debt item will help the features in the future. And this gives us the alignment between business and engineering. Business shows what the features are being present in the roadmap, how they are prioritized. Engineering provides technical debt and maps it on the upcoming features. And we can quantify the so-called CoDVA index, which is providing us good understanding how we may prioritize technical debt. Then this whole stuff is being done automatically. So whenever there are changes in business priorities, it is recalculated automatically. And this is the beauty of the solution here. Then we've got automatically prioritized technical debt. It lands together with features with a specific amount of effort allocated in the backlog of the team. Finally, during sprints, it is being repaid where it brings value the most. And now I'm translating this into math. So bear with me, but I will be just showing most important items here. Some technical debt items may be enablers for future. This should also for future technical debt reduction. So this also has to be taken into account. And the most important piece here is the estimation how big benefit we may expect by reducing technical debt considering features in the roadmap. So whatever I shown on the previous picture, it is being here translated into math to be able to quantify it and put it into any like sheet. It may be Excel or Google Sheet. Now I can show how this works in practice. First of all, we do have the mapping, similar as in previous picture, and initial quantification of this CoDVA index. We've got two planned releases, R1 and R2, and features F1, F2, and F3 with relative sizes as are being shown here. Then product manager is actually providing normalized feature priorities, and we are getting this automatically, taking the data from for example, AHA. Now, for all of these technical debt items, we do have estimations by the team. We know what is the roadmap scope stability, seeing the previous releases, how frequently the scope was changing, and quantification is there. Ultimately, we are getting the prioritization, TDI 3, 2, 1, and 4. And in that order, the engineering team would reduce technical debt. Excuse me, I will just grab some water. However, when the thing's changing and the business perspective drops to 0.6, this is not even very big change, we see that things are being reprioritized. After recalculating all of the values, we got different prioritization order, TDI 3, 1, 4, and 2. And here is the important clue for that. We see the technical debt item went from number 2 on the list to the bottom of the priority list because it was bound heavily to one feature, which was the prioritize. However, there are technical debt items which are important for the future, and they are called generic TDIs, which stayed as a top priority. And the ability to find this and to understand which are most important is crucial for us to improve the software in the areas which are really important for the future. However, in theory and practice are the same, but in practice, well, sometimes we may face some challenges. So considering our way, because this experiment was being developed over a couple of years, actually 3 years, and there were a couple of big technical debt items reduced, we saw a few challenges. So we see that actually it didn't follow, the red line didn't follow the blue. Blue is ideal CoDVA recommendation, and the red, well, is trying together, but not always. What was the problem or what was the challenge? Some of the technical debt items were simply too big to be prioritized. They were of size of a big features. And actually, only after they were split into smaller chunks, they were able to be prioritized. Second challenge was that some of the technical debt items were enablers for other technical debt items. So simply, they need to wait in the queue. And last but not least, and from the other side, some of the technical debt items were actually done faster because it was a context-based refactoring. When there was a couple of defects, a couple of features in the same area, the development team did it kind of aside of the normal work because it was easy to prioritize and actually didn't take as much effort as if they were done separately. So these were the challenges we were actually seeing. And looking into review mirror of what actually was done. So When we saw business prioritization done by engineering where was trying to predict what is worth to invest in, we saw the benefit when we followed the CoDVA by 27%. Then we saw productivity improvement. So considering velocity of engineering team, it went up to 39%. Then delivery predictability, so ability to deliver faster and actually having less issues with stabilization of the product also grow. So we saw that benefit across all of these productivity metrics were present. Ultimately, also we did the survey with engineering. So they responded then in 86% of the cases, this was taken from the whole team, the developer satisfaction grew across technical decision made, across the satisfaction of working with the product code, and actually across the testing capabilities and stability of the solution as a whole. What are the limitations? We need to think when we can use this model. We need to have, first of all, stable development environment, stable processes, so we can get this information when we need it. When we have product which is actually already in the maintenance stage, we will not benefit much from the solution. Prerequisites, structured business process, we need to see this. And we need to be able to have this open communication between business and engineering and redirecting this tension from budgeting to actually consequences of technical debt. Over time, when we provide more and more benefits with delivering faster, this tension is getting lower. It's important to start. So if I just leave you with like one item or one thought, it's a quote from Wayne Gretzky, a famous hockey player. I skate to where the puck is going to be, not where it has been. I need to take into account where the business is going to take our product and reduce technical debt there, not just reduce everything everywhere, because it brings simply no benefits. And actually, when we invest in that areas, the things are moving faster and faster, and we are actually getting better. So to find more details on that, there was a paper published in Information and Software Technology Journal, and there were a couple of conference talks over the years when the idea was reshaped and finally done and enabled also this PhD defense at the end. So thank you, and it's now time for questions.
Okay, thanks for the presentation. I have actually two questions. One is around product manager. You mentioned that he or she is like talking about value, and this is like leading to priorities. What to do in case that product management, okay, leave us a space for paying back the debt. However, like it leaves us doing by yourself. I don't want to take care about prioritization, about the talking about value. This is your role to your business to like taking care about this. And second question, how to deal, what from your experience with tech debt which blocks development, current development. For example, I don't talking about maintenance. I'm talking about like new products that are fast growing. And there's like attention to fast development, and we see that we have tech debt, and there's like architectural changes, and it stops development, post development, and there's like a path to convince product management to like doing this stuff.
Great questions. So to answering the first one, I was actually in the position that I had like 5 or 6 different PDMs where they simply had different thoughts about the product. And ultimately, we agreed that we need to get this prioritized list. They provided this input in AHA, but even having this input like as a list, considering a couple of releases ahead, you get the sense what is most important right now, what will be most important in the next quarter, and so on. So you can use this information to plug into the model as well. Maybe it will be that perfect, but at least you will have this differentiation of importance among features on the list. And this is enough to start working on that. So that's the first answer. Considering the second, if we actually stopping the development, so I would ask like 2 questions. If we are unable to deliver value to the customer, we are unable to deliver feature, so whatever we are doing should be part of the feature. Otherwise, we are not delivering anything. So 0 value means no functionality. So how we may say that we are ready if we are not? But considering the challenges to convince, it depends on what actually we are going to change and what will improve and how much. So I had the challenge, and I showed this, that we didn't follow CoDVA fully, that some really big changes had to be simply split into smaller chunks. So trying to find the way to deliver it into smaller parts over a couple of releases helped us to move forward with items which were constantly being postponed. So this was the approach the team took during this experiment, actually during this case study. Did I answer your question? Okay. Any further questions?
One, two, three. More questions? Thank you.